Hi everyone. Good afternoon to the last talk in this room, and welcome to B-Sides. So in case you didn't know, we are in Breaking Ground 1, 2, 3. So I'm going to introduce our speaker, Jen Tong, and she will be giving a talk on why FIDO security keys and web authentication are awesome. So before we get started, just want to give a few messages and thank our sponsors. We've got Critical Stack, Valley Mail, Security Agency, Silence, Secure Code Warrior, and many more. And without them, we would not be able to make this event possible. Also, a quick note that this event is being live streamed, so please be mindful of your cell phones and turn them off or put them on silent so like that it doesn't disturb anything. At the end of the talk, we're going to have a couple minutes for a Q&A, so going to be passing the mic around. So if you have a question at the end, just raise your hand. And with that, I will turn it over to Jen.
Hi, everybody. How's it going?
Good.
How's your day been so far? Great. Yeah, mine's been awesome. I swear I haven't been cramming to polish the deck, but that's how conferences often are. So we're going to be talking about web authentication and FIDO. But before I get into the actual content, I'm going to ask you some questions. Because I usually talk to a slightly different kind of audience. I spend most of my time talking to software developers. This is one of my first times talking at a security conference. I'm excited about that. So I need to learn a little more about you. How many of you know what FIDO and web authentication are? Like what these things are? Okay, about half. How many of you use web authentication or FIDO keys today? 20%. Hopefully I can convince you to raise that number up a little bit, but still better than when I go to most software developer type stuff. How many of you in like an offensive security exercise, like red teaming or something, how many of you have taken over an account and used it to cause complete havoc? I'll get 30% in the room. Yeah, this is when I really started getting into web authentication, having had this experience and seeing how fun and horrible it can be at the same time. Thanks a lot for humoring me. So let me tell you a little bit about myself. Hi, I'm Jen Tong, as you heard just a moment ago. Professionally, I am a developer advocate at Google. My background is mostly in software engineering, a little bit in silicon, process, and robotics. But for the last 8 or so years, I've been doing developer advocacy, which means I go around with developers and help them make good decisions. In the past, a lot of this has been around like making good Google Glass apps or using Firebase right. But then around 2016, I started getting kind of scared of the state of security on the world and started turning my attention more towards security topics and the cloud and stuff. And it's been over those couple years that I've had the opportunity to explore a lot of different stuff. But web authentication is one of the things that's really kind of struck a chord with me. And I think it's really cool, and I hope I can share that with some of you. There's a couple of really big reasons, off the top, that I think make it awesome. One is that I can go to pretty much anyone, no matter what their role is, whether they just use Gmail or they're a software engineer or like a CIO or something, and I can talk to them about this topic and give them some actionable advice they can do right now. You don't have to be a software developer to get a lot of value out of this concept. So I think it's pretty cool. Hopefully, I can convince you of some of that. One more meta slide, a little bit about this presentation. As I said, most of my speaking is to software developers. So when you talk to software developers about security topics, you got to kind of start a few steps back. I've adjusted it. I've cut a lot of the fluff from this deck. So I'm trying to make it leaner, but it's still going to be a little bit different of a flow than you might have seen from other B-Sides talks. In other words, if it's not for you and you want to storm out and go find a different talk, I won't be offended. But I would love to talk to you about the topic later. The other thing is this is half intended to teach you about the tech and convince you that this is actually a useful technology, and the other half to convince you to hopefully use it yourself to protect some of your accounts or maybe deploy it at your organization. OK, let's get into actual content. Let's talk about context. Let's talk about authentication and the state of the authentication world as it exists today. So despite all of our best efforts, authentication looks pretty much like it looked 40, 50 years ago. We have logins, usernames, maybe email addresses. We have passwords. We type them in. We remember them. kinda. And the reason it's been so hard to kill is because passwords are just so usable. Most interesting computers have some way to input information into them, otherwise they're not terribly useful. There are some exceptions to that. So if you can put input into it to use it, you can probably put a password in. So it's very easy to implement. You just take the existing user input methods and you just use them for authentication instead. Yay, authentication done, move on to the next feature. But we've been plagued with problems the whole time. People have been choosing terrible passwords, since the 1960s. They're still choosing terrible ones today. I could probably update this slide, but the data is still going to be the same. Nothing has changed. It's sad. And even way back in the 1970s, we realized that this was a problem. We were really worried about people selecting bad, easily guessable passwords, and then some person in a hoodie coming along and guessing their password on the mainframe or whatever, and typing it in and causing those problems. And way back then, we came up with techniques to try and help people come up with better passwords. We came up with policies, hey, use these things to make passwords that are safer and harder to guess. And me, with my software developer hat on, probably implemented a bunch of these things server-side. Because rules like this are really easy to write in code. This is only a few lines of code. And we hope that people will come up with high entropy, wonderful passwords like this. But we know the reality is they came up with passwords like this. Hence the name of the track that this talk is part of. And even if we were fortunate and somehow through training we convinced someone to come up with a really nice, wonderfully, difficult to guess password, we didn't see the other thing coming years and years ago, which was they remembered that password, but now they have 700 accounts scattered across the internet instead of just 3 accounts on a mainframe or whatever. So they take that super secure password, and if it's good enough for their bank, it should be good enough for their email and good enough for their employer. Which is exactly what gave rise to another threat. People realized this was happening. So rather than go after XYZ Bank, they would go after some fun new mobile game, or even just make a fake one altogether just to harvest credentials. Either way, they get access to those credentials, a combination of breach services, bad technique that somebody else did, and then our same old friend in the hoodie comes along and starts stuffing those credentials into a whole bunch of other services. And bad things have happened. Ironically, if people had gone against some of our early advice and just written those things down on Post-it notes and stuck it to their computer and used a different password for each service, they might be in a better place today. But I digress. But it's OK. Years and years ago, we came up with another way to help defend against guessing and also, coincidentally, against credential stuffing type attacks, which is one-time passwords. And they're really cool. Kind of cumbersome sometimes. The idea is you get a code from somewhere, either sent via some other previously decided upon trusted back channel like SMS or email, or you share a secret ahead of time and use that to generate these codes with hashing, either on a mobile app or with a dedicated hardware device. And they're great and all. They protect against the credential stuffing. We're in a much better place than we were before, but phishing, where someone kicks up a fake service, convinces someone to type in their OTP, still a problem. And one of the things I encounter with software developer audiences is a lot of people think phishing is a solved problem if they have OTP deployed, because those one-time passwords can time out. And they don't understand that the threats have kind of moved ahead, and that's not really true anymore at all. People aren't using 5-year-old OTPs. They're not trying to. They'll just man in the middle and do it in real time. So this is still a threat. And I think that the fundamental issue isn't really about user training, although user training does help a lot. I think the fundamental issue is a cognitive load. Because our users don't have some telepathic link with a third-party service to transmit that secret over. They're burdened by technology. They have to interact with some kind of user interface. And then they have to, what we're telling them to do is to evaluate all of those interfaces, which vary greatly from one platform to another, from one device to another, and use a bunch of rules to make your best guess if this is the real site, or if you've somehow been tricked into going to some random third-party site. And although you tell people, and when they're at their highest mental capacity, when you're talking to them during a talk or whatever, it's no, this can never happen. But it's still really effective. The data shows that it's very effective. And especially if you target and you find someone who hasn't had their coffee yet, and they're in the process of buying a house and have been trained to click on DocuSign links left and right, you can get around, you can trick people into doing almost anything. So we need to find a way that reduces this cognitive load and allows us to have secure authentication. And that's what we're going to be spending the next 40 minutes or so talking about. And the solution's obviously FIDO and WebAuthn. What I'm going to do now is I'm going to kind of go through it a layer at a time, starting from the most abstract kind of hand-wavy levels, and then adding layers of complexity and reality to it. And the reason I take this approach is because if I have a mixed audience and people start to doze off in the middle, at least hopefully they got some value towards the beginning and have some understanding. At least at this point, they hopefully understand that something does exist that's better than a password and one-time password. So to that end, we're going to talk about the solution in the abstract. Then we're going to concretify it a little bit with FIDO and the WebAuthn protocols. And then we'll have enough to talk about using it to protect yourself and your accounts. And then finally, with the time left, we're going to talk about implementation on your own service so that your users can be protected too. Yay. OK, an abstract solution. How math can save us. Because math always solves our problems, right? Creates new ones for me. Despite having a math minor, I still find math painful.
But it's hard.
It is hard, but awesome. And it comes back to public key cryptography. Because there are all these cool mathematical things. There are actually several different techniques we can do to generate private and public keys in pairs. Yay. And they have a neat property that if you use them to either sign or encrypt something, it can only be accessed if you have access to the other key. And a lot of people superficially think that this is just about sharing secrets, but we can also use it for authentication. And that's where we can start to talk about an abstract scheme where we use public key cryptography to authenticate users. So for this and any other authentication scheme, we're going to have a couple of different phases. And you're going to grow tired of it by the end of this talk, because I'm going to break this down into the registration phase and the authentication phase over and over and over again. Registration is about setting up that initial identity, doing that initial trust. And then authentication is about verifying that the same user who did the registration is the one who is present. So let's do some sequencey diagramming stuff for registration. We have a user. Our user wants to use some kind of service. Probably something cool. It's probably a mobile game. They somehow generate a key pair, as if by magic. Maybe they do it by hand on a notebook. You could do that. It would probably take a while. We don't care right now, because we're still in the land of abstract ideas. They securely transmit one of those keys over, which they now declare the public key. Fortunately, we have wonderful technology for secure transport on the internet, transport layer security. And the FIDO and WebAuthn protocols rely on that existing for some of the verification, which will come up later. But we can just assume we toss that key over in a secure way. The server stores that public key. Yay! Registration is done. It was easy, wasn't it? Now we can move on to authentication. So our user's already enrolled, essentially. The public key lives at the server. The private key is being kept secret by the user. And when they want to log in, the next time, the server goes, hey, we did a key exchange before. I'm going to generate a bunch of random characters, and I'm going to send them over to you. I want you to sign them with the key that you have, that you've kept private, and then send them back to me. So the user does that. Then the server can then verify that that signature is accessible by using their public key. The signature is correct, that it matches the challenge. And ta-da! We've now successfully authenticated the user. So it's really that easy at the highest level. But of course, the devil is in the details. There's like a million little corner cases where things can go wrong. But I just wanted to get the highest level, most abstract part of the story out first. So let's take that super simple three-bubble diagram, and let's concretify it. Let's make it actually useful. Let's make up some new words. And we're going to do that in, of course, the software engineering way with protocols. Who doesn't love reading protocol documentation? I actually like it. It's probably why I'm talking about this right now. So to take it to the next level of concreteness away from abstraction, we're going to need a protocol that we can use to have a common way of doing this interchange that hopefully doesn't involve generating key pairs in a notebook by hand. And it's going to have something to do with hardware at some point, because that's, that is that intermediate part that I want people to stop evaluating with their eyes and little mental model of heuristics. So let's dive into the protocol. This is hopefully the place where I save you reading through the entire set of specifications, which is only a couple hundred pages, but it's a little dense. It's better than Bluetooth. Oh, gosh. So once you start reading into the specification, or even if you read articles that people have written about this topic, you're going to kind of hit jargon really thick, really fast. So before we go through that protocol in a little more detail, let's do a little bit of jargon, glossary, defining some terms. So FIDO2 is the umbrella term. It is the container for all of the other protocols around authentication. And it's a little bit hairy, because if you see FIDO without a number 2, it could be referring to the standards body, or it could be referring to the previous version of the protocol, depending on which specification document you read. But if you see FIDO and the number 2 in a contiguous word, it refers to the protocol. There was a little bit of renaming of stuff when FIDO2 came out. You have the servers you authenticate with. These are called relying parties, or RP, all over the spec. So if you see RP even in the actual messages being passed, it refers to the relying party. We have different kinds of authenticators. We have platform authenticators, which means they are built into something else, a more general purpose computer. And we have removable security dongle style authenticators. They're also called roaming in a few places in the spec. Those authenticators communicate with the user's client, their web browser, over another protocol, which is called CTAP2. It could also be referred to as or rather, if the 2 is missing, it is referring to the older version of the spec, CTAP1, which has been, the terms got rearranged. They kind of rewrote history a little bit and decided that that also means U2F. But if you read old docs, a lot of people use U2F to refer to the overall old protocol, which I guess would be FIDO1 now in the new terms. Anyway, there are 2 different wire protocols that the authenticators can use. They're both still secure. There hasn't been any huge flaw discovered in CTAP1. But CTAP2 came along with slightly better binary encoding, a little bit easier to use. We also got a few more bells and whistles in the feature set. But if you have a CTAP1 device, it's still going to work in the FIDO2 spec. And then finally, WebAuthn comes in. This actually defines the protocol that is used by the application running in the web browser or the mobile app, and the way it communicates with the server and some of the APIs on the server side. And this is a W3C spec. So I use this a lot to communicate this, because this is one of the only non-ambiguous terms in the entire set of protocols. Everything else is a little bit confusing. So it's a good term to hook onto. OK, we have terms. Let's go through those same 2 ceremonies, or as I like to call them, dances. Let's go through the 2 dances again. First, registration, and then authentication. So now we have a slightly more concrete world. Our user has a little security key with themselves. And I'm going to assume that when they're registering, they're already authenticated. Either this is happening as a result of the fact that they just signed up for your service and you're taking them through this next step, or they're already an authenticated user and they're coming back to add a key long after the fact, which is the much more common case. And they want to add a key to their server, the relying party. So the user tells the relying party, I want to register a key. Great. The server sends back a whole bunch of stuff, but there are a couple of things that are kind of key. They send back a challenge, a cryptographically good, pretty long string of stuff. So this is used both for the verification, but this is also used as a potential source of entropy by the key. So this has got to be good randomness. And I think it's up to 68 bytes long or something now. And also a relying party ID. I think it's just RPID in the actual wire protocol. And this should match the domain name of whatever they're communicating with. That's used to help prevent the phishing. Once the client gets that, it's going to re-encode it, send it over to the key, which is going to do a little bit of verification. It's going to verify that that relying party matches the domain name that's visible, the origin. And it's going to make sure that it supports all the features that have been requested. And then it's going to generate the key pair, either using its own internal entropy source or using the entropy from the challenge. It's going to send back a payload back up to the relying party, which includes the signed challenge, the public key that was generated on the authenticator, the origin that it saw so that we can do domain verification yet again server side, and a credential ID that's been generated by the authenticator, which it expects the server to store. So the server is going to verify all that stuff. It's going to save the public key and the credential ID for later recall. And then it's going to make a counter and set it to 0, which will be useful later for some reason, which we'll get to in a sec. OK, with this, registration is done. You can tell the user, hey, you're done. Good to go. Go have fun. Later, the user comes back. It's time to authenticate. Let's take a look at this one again. So the user probably does an existing method of login, although the spec has some other cases. We're just going to talk about the boring case everyone's implementing now. They'll log in with their primary authentication, a login and a password probably. And then the server's going to be like, hey, you have registered some security keys. I want to verify for sure that you're who you say you are. So let's do the authentication dance. It's going to send over credential IDs, which you can actually send over a whole list of credential IDs. You have one credential ID for every single authenticator that corresponds to that user. You want to be able to store multiple authenticators for users. You also generate yet another challenge. You generate a lot of challenges server side. Send it on over. The user and their client's going to do another set of verifications. It's going to use that credential ID. I dropped ID from the slide. It's going to use the credential ID to find the private key that corresponds to, that it wants to use to do the signing. It's going to increment its own internal counter, which is a little strange on the first time you've authenticated, because you're just incrementing an arbitrary counter. You haven't actually told it to the server yet, but it doesn't need to know yet. And you're going to sign off the challenge and sign the whole big old blob. So we're going to send that all back with our incremented counter. And we're sending the origin back over again also, which gives the server yet one more chance to verify that there hasn't been anyone sitting in the middle with a different TLS certificate and a different domain. We can verify that the challenge is indeed correct using our mathematical awesomeness. And then there's a weird step. We verify that the counter is higher than the counter that we have stored. So the spec actually dictates that the counter is a positive integer. And often it's shared across multiple services on the authenticator itself. And what this kind of weird looking feature does is it helps you detect cloned keys. So there haven't been any cases known yet of people cloning these authenticators, but the spec actually assumes that someday someone will start cloning authenticators. And you can't tell clones apart if they're good enough clones, but this hopefully gives you an ability to detect that those clones exist. So the second time, or rather the first time someone authenticates with the second device, which could either be the clone or the original, you can detect that a clone does exist, and you can log out the account or make little red lights flash or whatever you want to have happen. And with that, we have now successfully authenticated. So that's the slightly more complete dance. And hopefully at this point, we're pretty confident now that, well, we can detect clones, obviously, but also that we're pretty good at detecting phishing. We've taken the user's burden of having to identify their domain name correctly and all that other stuff. We've taken that part out, and we're using hardware now to verify that origin matches that relying party ID, which is a huge win right there. Yay! OK. So now we're done with that part. Let's talk a little bit about the hardware that makes this possible. So there's a whole bunch of different devices out there. These are the first ones that came out. These are the dedicated devices, little security dongles. They come in a whole bunch of different form factors, and they communicate with host devices using USB, human interface device, or near field communication, or if you're on iOS, you have to use Bluetooth, which is not a wonderful experience, but it kind of works. And these are great at all. They have some specific advantages. One advantage is that they're isolated hardware. So if someone were to like compromise my laptop, the hope is it would be difficult for them then to compromise the key when I plug it in, because these are also small. Like a lot of these are very simple devices. So they have a small attack surface. So the hope is that that's very difficult. So the private key on here remains safe. Another benefit is I can move them from platform to platform. So I can use the same one on multiple computers. I can use it on my phone, and so on. So I can bring it around, bring it with me. And another benefit is if there's ever a hardware flaw discovered, it's very easy to swap out this. I just reprovision and then mail out a bunch of these devices if like a flaw is discovered in the previous batch of them. If I want to change to a different vendor, it's costly, but like pretty straightforward to just mail out new keys and invalidate the old ones. But the newest version of the spec also brings platform authenticators, which are not as good in some ways as roaming authenticators, but they have the wonderful property of already being in so many people's pockets. Because everyone's running around now with cell phones that have these really awesome secure hardware enclaves inside that are secured with biometric presence detectors on the device. And that's pretty cool. That's better than the password written down in a notebook. And this is one of the big features in FIDO 2 that's available now on a lot of sites. And I think it's what's actually going to start to allow us to get some traction and get this actually deployed out to a whole bunch of consumer services. OK, so we've talked about the keys. We talked about the protocol. Let's talk about the practicality of it. Let's talk about using this as a user today. Because one thing I'm hoping to accomplish by this is have some more people dust off the authenticator that's been sitting in your drawer for 2 years from when you drop by like a Yubico table at a conference or something, and actually start using it on your accounts. So step one is get an authenticator. There are a lot of different manufacturers of them out there. Yubico is an awesome one. They make authenticators with all sorts of bells and whistles that go beyond just the WebAuthn spec. So the little security dongles they sell come in all sorts of cool form factors, but they also have a whole bunch of other features like PGP signing, and like you can use it to secure your SSH. It has like smart card features and stuff like that. They're cool. They're a little more on the expensive end. They also have like enterprise support and that kind of stuff. So they're a good option. If you are more on the open source kind of hackery side, the one I'm holding right now, these are my favorite. These are the Solo keys and their predecessor U2F0, which are open source hardware and open source software. So you could theoretically go get everything down and go make your own run of keys, modify the firmware, and set it up so only your employees have to use the keys you gave them. But you can also just buy them on Amazon from the first batch, which is kind of nice. They're cool. And Google, of course, has a kit we think is neat that comes with two, a Bluetooth and an NFC one. So I definitely recommend if you get them, get multiples. Have a backup. Ours comes with a backup. OK, so you got your keys somehow. You bumped into me at the right time, and I had something to hand out, something like that. Next step is actually register it on your important sites. The first site I almost always try to urge people to do is like GitHub or GitLab, both of which have support. How many of you have open source projects out there that a lot of people use? Or how many of you have commit access to open source projects that a lot of people use? A couple people, not too many. This is a much bigger issue in software development. I'll go to a software conference and 30% of the people will raise their hands, and then I'm just scared that someone's going to go pwn their GitHub and introduce a bunch of malicious code into it. But I'm going to take a minute, and I'm going to make you watch registering and authenticating a key. It won't be that bad, I promise. So here I am on GitHub. I am already authenticated. I'm going to go on up, go on down to settings. For enabling a security key on GitHub, you have to already have two-factor auth enabled. So you'll see that it's already enabled. Oh, and just below it in the corner, you can see a little webcam of the Solo key I'm holding. So you go find the security key section. It's usually called security keys on most services, and you click on add. Exciting. You scroll past all the warnings about getting locked out. Ignore those for now. Register your device. Give it a nickname. You can call it Solo Key or Han or whatever you want to call it. Hit add, and then this is when it's going to start using the WebAuthn. You can see the key is blinking yellow and green, which means it wants a touch. So you poke it, and you're registered. At this point, you might want to go set up backup, second factor authentication, or register a second key. But let's go ahead and use it to log in. So I put in my username, my very secure, super long password, and it knowing that I have a browser that supports WebAuthn and that I have a previously registered key is going to ask me to go tap that key. I tap it, and it's done. Way faster than using an OTP. Once you actually have these worked into your workflow, it's actually way more convenient than like either getting out a T-Top app and reading off the codes or waiting for a code to get delivered by email or something. So not too bad. About a minute for the whole flow, and it only adds a couple seconds to authentication each time. And I showed you GitHub, but there's a lot of other places that are supporting, and more people are adding support every day, which is awesome. There's registries out there. Places are often really bad about advertising their support for it. Sometimes you have to like find the secret links to the registration page, which is like, we'll get there. But one of my favorite kind of registries or lists of the sites of support is WebAuthn.info, which has a great name. NitroKey made it. And you can go down here and you can go find different things by category to check to see. And we can see that like email, there's actually a lot of providers that have pretty good support. Fastmail has a really good implementation. Gmail. But some other categories are not as happy, like cloud computing. Amazon Web Services has an implementation now. Google Cloud Platform has a great one. Wink, wink. Don't judge. But there are some other categories that are really sad, like investing. No one has support except for Vanguard, and Vanguard's implementation is like not great. They only support UB co-brand keys, and they only support one key per account. It's like, oh, come on, almost. So I keep an eye on those pretty regularly just to make sure that I'm using it everywhere I can. Because once you have one key and you're carrying it around anyway, the more places you use it, the better. You've already invested the effort in carrying a dongle around. OK, so now we're at the point where hopefully we've applied it to all of our important services, our email, where we keep our source code. Maybe someplace we invest or something like that. Things are protected. Things are a little happier. We think it's going pretty well. And people are starting to ask us, like, hey, what's that thing you're carrying around? It makes me stay secure. So let's talk about adding it to your software so that your users can be as paranoid as you. So this is usually the point where I'd want to like jump out and live code an implementation on a toy application, like add it to my cat picture application. It's not quite there yet. And I've tried a few times. I can't get a non-broken implementation in under 500 or 600 lines of code yet. So instead, I'm going to kind of give you advice on implementing it today if you want to go run out and deploy it at your organization or something like that. So the first thing is the client libraries are actually in pretty good shape now. They've come a long way in the last couple years. The best way, you can just search GitHub or Google to find them, but WebAuthn.io has a pretty good list of them, actually. And but they're at different levels of maturity. There are a few of them that are pretty mature now, and I might trust to drop into a production implementation. The other ones are pretty young. If you are ready to go start deploying this, like this is one of those projects where expect to spend some time reviewing the code of the third-party library you're including. It's useful sometimes. This is one of those times where it's going to be useful. And the other part is the client libraries pretty much focus on the server side component only. They don't do much of the lifting on the client side. So you're going to be writing some complex web application code or complex mobile application code on your own. There's not really any libraries to handle that yet. But this is pretty reasonable. The library developers are doing a pretty good job of targeting the stuff that I think is most error-prone. Like all the cryptography stuff is pretty much taken care of, which you'll want to review, but you don't have to reinvent yourself. Yay! OK, so rather than code it for you, rather than take you through a bunch of slides with code snippets on them, I'm going to show you somebody else's really cool website where they give a pretty nice walkthrough of implementing it. And this one is on a wonderful website called WebAuthn.guide, which features beautiful illustrations and really cute graphics. But the reason I like it a lot is because it has kind of the best, here's some code step by step of implementing it in JavaScript. So we're going to do that same two dances again. We're going to go through the registration dance, and I'm going to kind of talk about some of the corners, some of the rough edges on the spec from the implementations I've done. And then we're going to do the authentication step, which has a bigger cartoon but less code. So web authentication itself, the core is just 2 web browser methods you need to run. So it seems easy, right? Kinda. So it's just this one web browser thing you have to run to initiate the registration, to start the registration process, to get the browser to ask for that initial key for registration. But that one parameter it takes is actually quite a monster parameter. You have to send it a few things. Like one of the required ones is you have to send that initial challenge, which for some reason you have to give it to the API as not as like a base 64 encoded string as something, but instead as an array of integers. I don't know why they picked that. I have not cornered anyone and asked them angrily enough yet. You have to give some relying party information, not too much of a surprise. This includes, the ID is important here. The name is just optics. It shows up on the prompt the user gets. But the ID should match the origin of the domain that you're using to do all of this brokering. Or it's going to say like, hey, this looks like phishing. Some user information, which is why registration happens after the initial account creation, because this is part of it. You have an ID that you give that does not necessarily have to be cryptographically secure, but can't contain any PII. Like it can't be a human readable username per the spec. There's a name that is human readable and a display name that is oddly required. And the spec is also a little bit unclear on if a user profile icon is required, which some libraries will make you do, and other libraries just stick a random URL like example.com in for. I'm curious about the meeting that resulted in that. But this is the name that's going to get bubbled up back to the user later. And then you can specify a bunch of stuff. Most of this stuff is like the encryption algorithm you can use. Like there's just 3 that are required by keys right now, and every key I've managed to get my hands on supports exactly those 3. So the client library takes care of some of this stuff, usually automatically. Timeout is technically an optional parameter, but all the browsers default to like 100 milliseconds or something, which is not enough time for someone to touch the key. So it's really required pragmatically. So set it to like a minute or something. And then finally, a really cool feature is attestation, which a lot of client libraries specify direct. You have 3 different options here. You can either do direct, or indirect, or none. And what this does is you are querying the key itself. You're saying during registration, I want all the certificate. I want the certificate off the key. I want all the details of the key's manufacturer, essentially. If you set it to direct, you're going to get all that stuff. So this is a little bit privacy compromising, because you could potentially use this to track a user across sites. A lot of client libraries default to direct, which is getting the most information from the key. But this will cause your users to get an extra privacy warning. So for consumer-facing services, set this to none. Like you don't need to care too much about the implementation of the key they're using. You might want to use direct here. Like use cases I've seen that are common are like you have to be FedRAMP compliant, and you need to make sure you're only using FedRAMP keys. That would be a case where you set this to direct. Or if you have a banned manufacturer for some reason, you can do attestation direct here and then use that to blacklist that manufacturer during registration. So you send that off. You call the browser API, and this is not actually going to make any web requests. It's actually going to send a request to the key. So the key is going to start blinking, boop, 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 or whatever. And it will return this big old ball of stuff. You get back the credential ID. For some reason, you pass data in as arrays of integers, and you get data out as array buffers of binary data. I don't know why, but you do. So you get back all this binary data. These are the 2 things you care about the most, which are the client data JSON, which is kind of a log of the stuff, kind of a log of the conversation between the browser and the key. So you'll want to use that for further verification server side, like the anti-phishing stuff. And then the attestation object, which actually contains the public key and the certificate if you've requested it. These are unfortunately not in a format that's very easy to transmit over the wire. So you're going to have to re-encode these again, your base 64 encode them, and either stash them in a form and submit it, or use a JavaScript request to send it. Fire it off to the server. And at that point, the user probably has a little spinner now, but they've already tapped the button on their key. They're done with their step on the registration. And now it's our turn to go server side and actually verify this stuff. You're going to get back, those two different things are going to come back at a minimum. The client data, which was that kind of log of the conversation between the key and the browser. And mostly what you're doing here is verifying a bunch of stuff. You're verifying the challenge is going to get echoed back. You're going to verify that the echoed challenge is the same. You're going to verify that the origin that the security key saw is the same as the origin that you see of yourself, anti-phishing. And, but this is mostly handled by client libraries for you. The more interesting stuff comes when you get to the attestation object, where that public key and other stuff is. Here you're going to decode it once. You'll decode it again. And you get out these arrays. You have your attestation statement. This is if you did attestation direct, you're going to get this, which has a certificate. You can do your verifications to say that this is a bona fide awesome key. But if you have it set to none, you won't get as much there. But you will get auth data, which you then have to decode again. And this decoding is actually one of the nastiest parts. You're basically getting the wire protocol from the key sent all the way back to your server, which I guess is nice. Nobody's molested it or anything. But like it's untampered. But it's still like a pain. You got to like do a bunch of bit slicing to get it off. Fortunately, mercifully, all of the client libraries take care of this part. If the client library exists, this is the first thing they target, thankfully. And the client libraries will typically return to you a credential ID and a public key bytes. These are the two things you care about and you need to store. Assuming the client library said that this is all the 17 required steps of verification passed, you want to take these two things and store them, persist them in your database somehow. And at that point, registration is done, which happened really fast for the user, but you had to do a lot of stuff yourself. OK. So registration's done. A user might register multiple keys at this point, hopefully set up a backup authenticator or something like that. Now they're ready to log in the next time. Let's talk about the authentication flow. The cartoon is a little bit longer, but we're going to skip over that part. This is the web authentication method, navigator.credentials.get. Oh, one thing I forgot to mention. You can, if this method is defined, that's how you know if the browser supports web authentication or not. You can just ask it. Like if this method's there, you can call it. If not, this browser doesn't support it, like old school Safari or something. So again, you have some stuff that has to be generated by the server side to make this request. So like you either have to bake this into the authentication page or do a JavaScript request to get it. But you're going to get yet another challenge. And you're going to get an array of credential IDs. This is all the different credentials, all the different authenticators that are associated with that user. And what this allows, this is more of a kind of a response time thing. This allows the browser to kick out keys it doesn't recognize without doing a whole round trip. You can also specify transports here, which oddly you can't specify during registration, but you can specify during authentication. So if you want to prevent Bluetooth keys, you could do it here. But that's optional. Timeout, again, optional by spec, required by browsers. And then, yeah, you'll call that method, and you get back a bunch of blobs this time, which you have to do kind of the same game. You have to encode them into a format that you can send back over the wire, stuff it in a form, send it over JavaScript, something like that. You're going to get back at least these three things: the authenticator data, which is that signed challenge, and the counter. Client data JSON, pretty much the same as registration. It contains kind of a log of that conversation with all the domain names and origins and stuff. And the signature. User handle is something that has to do with a newer feature of FIDO2. You can actually store usernames on the keys in FIDO2. I haven't seen anybody use this yet. So I haven't really seen it beyond toy implementations. But it's cool. This is one of the features that works towards passwordless authentication. And mercifully, the server-side validation is actually much more straightforward for authentications. You really just check the signature and check the counter. You know, push it to your client library after you've decoded things a few times. And hooray, the user's authenticated. And if that's all gone well, like your basic authentication is in good shape. So with that, we have a rough idea of kind of the level of complexity that you're going to have to implement. Most of that code is code that people have to write every time right now, which is one of the reasons I think adoption is a little bit slower right now. But I think the value is going to start to pay off soon. So I have a few minutes left. So painful realities about doing implementations. Some of this comes from me talking to people who we did an implementation at Google several years ago. It's been awesome. talking to people doing that and talking to people using it in other places. One painful reality that people first think about is what about users losing keys? This is actually way less painful than you might expect. You just do the exact same thing you've been doing for years when they've forgotten their other authenticators, when they've lost their phone or lost access to a phone number or forgotten their passwords. You fall back to a fallback authentication. This could be something that's more secure, like making them go to the help desk in person and beg for a new key. Or this could be something that's less secure, like going back to like a TTOP one-time password. But the truth is, even if you use a less secure backup authentication, you're still going to get a bunch of the protections, because those people are going to be a little confused when they get prompted for one-time password if they're used to using a security key. You've now made their account safer, even if you have a less secure backup. Another painful reality is that iOS support is still lagging. This is looking like it's on the upswing. Safari's developer preview for desktop for macOS supports WebAuthn now, and it's a pretty good implementation. Yay! But iOS support is still like kind of kludgy right now and requires a lot of work on your part. I'm hoping that'll change real soon. As I said before, the client libraries are young. Expect to spend some time reviewing code. And if you are touching this, if you're doing any implementation, you are going to have to open up the spec still. I'm sorry, it's not that bad of a spec. As specs go, it's actually pretty okay. It's only a couple hundred pages. It's not like 4,000 pages like Bluetooth. So the last closing notes, if you're going to do an implementation, I want to encourage you to make some good choices. If you add support more than one key, please, so that people can have a backup key. Because be pragmatic. People are going to share accounts, especially like a social media account from a political campaign. Of course, 300 people have access to that Twitter account. Like, support multiple keys. Hint, hint, nudge, nudge. Twitter, please add support for multiple keys. Only use attestation and only limit key providers if you actually have a reason to. None is a good default to start with, unless you have a good reason to like only require FedRAMP approved keys. And then with that, I'll leave you with WebAuthn is cool. Anyone can go and use this knowledge today to make themselves safer, whether they're a developer or a security person or not. So thank you so much for hanging out with me this evening. Feel free to, if you want to talk about this later or now, let me know. We have a minute for maybe 1 or 2 questions. And here's a slide with a bunch of links to more resources and the slides themselves. Thanks, everyone. So in the 3 minutes left before the session is over and we can go find parties and stuff, does anyone have a question?
Just a quick question.
Sorry.
Oh, we have a question microphone.
So you talked about adoption on the consumer side, right? But I was wondering if you can share any experience about internal adoption at Google of this type of technology and strong authentication.
Yes, thank you. That's a great question. So we did start using this several years ago at Google. We were one of the earlier adopters to use it internally, and it has been that's one of the things that got me so excited about it. It has been like night and day in terms of the threat of account takeovers. It has really reduced that risk almost completely entirely away. So they're incredibly effective at preventing those account takeovers. I don't know how much detail I can go into. Like I'm aware of some of the details of the different operations involving like red teaming and stuff with it, but I don't want to go into too much detail there. But yes, they've been very effective. We've pretty much eliminated the risk of, or the concern about account takeovers of Google corporate accounts just by using U2F keys at the time. So super effective.
Have you looked at using the only key?
Using the only key.
So it's like the YubiKey, but it's got 6 different places to be able to go through input, and it's about the same cost of the YubiKey as well.
It's a YubiKey with 6 different inputs. I somehow missed the only key. I need to learn more about the only key. So there are some features built into it by the specification to prevent different sites from correlating you, even if they both go to the same database. Like one of the reasons that initial challenge has to be cryptographically secure is to prevent correlating accounts, even if they're authenticated with the same key. But I would always love to hear more about privacy-conscious features around this. Yep, question?
No. It's only a commentary because only key is open source too.
Oh, it's also open source. Yay! Oh.
So I've been wondering since I learned that Google implemented this to protect their accounts, is that just protecting their Google account or is that protecting their computers as well? What's your implementation like there?
So We primarily use them to protect our Google accounts, but we have little cryptographic hardware devices that are deployed. I'd have to look into more to see how much I can discuss about that.
Just a quick question. So when I go to some site and it says you can log in using your Google account or your Facebook account, is this the technology that they're using to do that?
So when you log into an account using kind of federated login, like log into Stack Overflow using your Google account, that's using OAuth, which is a little bit different. It's a different step of the process. They're doing a different dance with keys and tokens and stuff to accomplish that. But using OAuth is one way to get strong authentication on providers that don't directly support U2F or FIDO. You use a FIDO-backed account, like your Facebook account, which supports FIDO authentication, or your Google account or your Twitter account. And then if that's your source of authentication, then Google or Twitter or Facebook is going to go through the FIDO authentication step, and then they're going to finish that authentication dance. So you're just stacking ceremonies at that point.
Thank you.
Great question. Any other questions? Wow, answered all the questions. Well, if this is something you're interested in, or if you have things I may have missed, like OneKey, I definitely would love to hear from you either while we're at the conference or outside via the internet. Thanks a lot for coming, and I hope you have an awesome rest of your B-Sides and Hacker Summer Camp.